Welcome to the Customize Your Agent session at Agent Sessions Day. It's a bit of a mouthful, but I'm Courtney, a PM on the VS Code team, and the intent of this session is for you to leave with kind of like a handbook, a playbook for how you can customize GitHub Copilot for your team, their tools, the workflows that you guys do every day, and then how to onboard and where to start with them. So lots to cover in this session. Let's go ahead and jump in. So here's a lot of information on this slide about the different options that we have in VS Code. So we won't get to cover all of them in depth. There's lots of great resources on our docs and on our YouTube channel for you to use, but a high-level overview for you to keep in your back pocket to reference. We have instruction files, and instruction files are kind of like global context files. I consider these always on. And you can have the ones that load for every session that are really great for things like your code-based guardrails. So your overall architecture, like coding guidelines, things like that. Or you can have file-based instructions, which are patterns pattern and description match for specific areas. So like Python files only have a certain set of descriptions, or your test files have a certain set of descriptions as well. And these are matched using glob patterns. We also have prompts, which are really just those slash commands that you see in chat, best for your one-shot workflows. So shooting off, making tests or creating a PR, things like that. We also have custom agents, really cool. You can either reference them in the chat dropdown or via subagents, which we'll touch on later in the session. And these are best for your constrained workflows. So if you want to have specific tools or a model, you don't have to re-prompt and reconfigure this every time, but you can just work within a custom agent. We also have skills, which is something that's newer. These are similar to instruction files, so there's a little bit of overlap there, but the big differentiator for these is that these load on demand. So rather than them being always on, always included in your context, they'll load dynamically when they're most relevant to what the agent's working on. These are best for reusable capabilities. We have hooks as of our last stable release, which is awesome. And these are lifecycle triggers. And basically just contextual automation is the best way to think about it. So rather than you having to be mindful of what the agent should do at session start, session stop, pre-tool use, post-tool use, you can automate that with hooks. And then Connor had a great session on MCP earlier today, so I won't spend too much time, but I did want to put it on this slide so you have it for reference, but I definitely recommend going back and checking out his session on MCPs. So these are all the different ways that you can influence and steer how the AI will write code for you and work with you in your code base. We have system prompts to make Copilot generally successful, but like I said, it doesn't have all of the knowledge to work best for you and your team and their workflows, and that's what all of these different customization options are best for. So to start, we'll dive a little deeper for instructions. Like I said, these are always on context, and they can be global or file specific. So in this example here, I have ones that are specific to Python files. So they're only going to be included or pulled in when when the agent needs context for working on Python files. Some best practices here are to be specific. So don't just say you want a testing framework, but say you're using PyTest, for example, for Python instructions. You should also include reasoning where relevant so that the agent knows exactly why it should be doing what it should be doing so it doesn't go off the rails. I also like to opt for code examples where relevant so that it can source relevant information. And like I said, just have very specific instructions on like what it should be doing and what it should be looking at. And then to avoid any context bloat, also skip any rules that linters or formatters already enforce, because these are always on, and so you don't want to, like I said, bloat the context window with things that are already covered elsewhere. Similar to instructions are skills. The main difference here, like I said in the overview, is that rather than them being always on, they're loaded dynamically. So the agent is only going to pull them in when it feels like it's relevant. And we'll see this in action in a little bit in VS Code. But I think that's the best way that I can conceptually separate those two, since there is a considerable amount of overlap. And skills can also include scripts, examples, and other resources as well. So it's a good way to like add capabilities to the agent rather than just having a generic always on context. So it tailors capabilities for domain-specific tasks without repeating the context, and then we'll load them in on demand. So let's go jump into VS Code really quick, and we will talk about skills versus instructions and kind of how we can monitor what's being pulled in VS Code, because I think it's interesting to talk about these concepts in a way that's very abstract. But if you can't tell in VS Code actually what's being pulled in, is it working? Like, are these kind of like fluffy abstract concepts are in my repo, but whether or not they're actually working is a whole different story. So in VS Code, we have my arcade app. I love to just play with this, when I'm bored, and build on it when I can. So it has a classic Snake game, 2048, which has been my game of choice recently, Tetris, and then the good old Flappy Bird as well. And then we'll see that I already have a Copilot instructions file in here, and it covers like architecture elements, has some build and test things, conventions, but it's relatively short. And then I also have in my skills folder, I have a debug skill. So I was finding that a lot of times when Copilot was building out new games, we were running into this like similar debugging issues. And so Copilot helped me create a skill that was specific for like looking for problems that are relevant to these games that I was building. So if we just ask Copilot, like, what is this repo? We'll be able to see off the bat, it's pulling in my instructions file here. So this is, it's just describing to me what this repo is, but it's also looking at our instructions. So it's a good way to demonstrate that always on context that we talked about. The other cool way to kind of monitor this is in the chat debug log. If you don't see this in your activity bar, you can also go into the command palette and look up chat debug, and it'll open this same view. And essentially this gives you the opportunity to see all of the tool calls, all of the background for what's being passed to and from the models. So you can see that if I click on what is this repo, that's my chat request, we have the system prompt, and then if I also look up for Copilot instructions, is I think what the thing is called. Yeah, so it's pulling in my instruction files as well. But if I am trying to fix a specific bug in my game, I say help me debug an issue where my keystrokes aren't always working. And I fire that off to the agent. I'll close this out. But you can see it's picking up my skill automatically. So this debug skill is being pulled in, it's reviewing it, and then we can also, in the debug logs, I believe it might be this one. Yeah, so it's reading my skill file, which is super cool. It's doing it automatically just based on the naming and the description of the skill file, which is just all formatted in Markdown. So yeah, that's just a little bit about skills versus instructions, how to access them. Going back into our slides, the next thing that I want to cover is prompts. And prompts are those slash commands that we see. They're best for one-shot workflows. And so similar to skills and similar to instructions, this is another Markdown file. All of this is really just boiling down to Markdown files if you haven't caught on already. But the cool thing about prompts is that you can just, instead of asking the agent every time to like reprompting and reconfiguring your tools, you can just put this all into a prompt file, and then it makes it really easy to just like fire it off and forget it. So it is best for common tasks. Think like clean up my PR before I create my PR /test to generate tests, and they're stored and accessible via the chat input. The other sort of user-invoked idea that we have for customizations is custom agents. And I always describe these as role-based personas. So on this screen, I have an example of our plan agent. This is built into VS Code, and you can access this file, this Markdown file, in VS Code yourself. I can show you how to do that, but basically these, again, Markdown files, but this is specifically outlining a planner on your team, for example. So their whole job is to just create a plan for how to actually execute, not actually execute. And it has a certain tools, it can have a certain model that it's using, and then also does the cool thing about with handoffs. So you can see that part of the metadata in this Markdown file has a handoff section, and it will basically take from the plan and then push into implementation, which is actually like executing on the plan. And this can be automated where like it doesn't require any manual work on your part as the user. It'll just pass off automatically. Or if you want to have that kind of like checkpoint guardrail feature, you can manually click a button to pass it off. So you may want to create custom agents for like a security reviewer, a very like specific type of planner, or a solution architect, or any other specialized role that you see your team kind of like having. And then each persona has its own behavior tools and instructions, and it allows you to constrain the behavior. And as I mentioned at the beginning, custom subagents can either be specifically invoked via the dropdown or as subagents. And subagents is a really cool concept that I think some of our other presenters have already touched on. But what I really want to talk about here is that subagents run in their own context window. So we recently added the context widget in the chat input box that shows you how the context window is being used and consumed throughout your chat request. And subagents basically run in a contained context window. This works really great because that means it's getting input from the orchestrator agent. It's doing all of the research, all of the digging, and then it's only returning what is relevant back to the orchestrator, and all of that additional search context isn't included and isn't bloating your context window. So it really helps with like parallelization of tasks, and the main agent's context really stays clean and focused, but it can make your workflows move a lot faster. And so I'm going to talk about what this looks like in VS Code. Let's go back to my VS Code. I'm going to close out of all of these funky tabs so we have a better idea. But if we go back to my agents, here I have an accessibility agent, a game maker agent, a janitor agent. I have all sorts of different agents here. And they have different tool configurations and then prompts involved in them as well. But if I want to go, I'll start a new chat. Speaking of clean context, I can have this say, since I have a game maker agent, I can set here, or I can have it say, create a new Minesweeper game. What else do I have in my agents? Drop down. What else can I have it do? Check for, accessibility concerns in my project and clean up any dead code. Dead or redundant code. Okay, so with subagents, you don't have to necessarily tell the agent to run it as a subagent. You can, typically it'll figure it out by itself, but for purposes of this demo, and just to ensure that we get to see this in action, I'm gonna say, but run these as subagents. Okay, fingers crossed this works. Live demo, we'll see. Okay, so it's thinking. It looks like it's saying, like it's picking up the agents, the experts that these different to-dos rely on. That's a good sign. Oh, okay, perfect. So now we see that these are running in parallel. So this is what you're looking for. It's kind of this shimmer in chat specifically. And we have the game maker agent, the accessibility expert, and then the universal janitor. And we see each of them working stream in at this top level. And we can expand these and see all of the work that it's doing in parallel. And then one of these might finish faster than the others, and they'll keep working. I imagine the Game Maker agent is going to work for quite some time, creating a Minesweeper game, but cool. Yeah, the accessibility agent is done, and it looks like, let's see what it reports back. So this is the audit report that it's sending back. And this is getting sent back to this main orchestrator agent to then go like actually execute on, if the accessibility agent didn't already do that. So that's cool. Whereas the janitor agent is gonna take a little bit longer. Looks like already added 535 lines of code. It's working fast. Let's see. Okay. Cool. Well, I am gonna let that roll a little bit longer and then go back to our PowerPoint. Looks like we lost it. Let's see if I can reopen it. Let's see. Because the last thing that I want to talk about is brand new in VS Code, and it's relevant to hooks. So for hooks, they're new in the latest VS Code release, the latest VS Code stable release. And like I said before, it's great to enforce policies at different times in the process, the agent execution process, for example. Let's get back to our PowerPoint slide, sorry. So it's a deterministic way to do code-driven automation. So what this means in practice is that it helps you enforce any security policies. So if you want to, before a tool goes off and fetches something, it can run some sort of like security check to make sure it's not fetching from dangerous URLs. It can automate code quality after agents make edits. It can create audit trails, control approvals, and things like that. And VS Code supports a bunch of different lifecycle triggers that you can use with hooks. And so it ranges from the session start to the session stop, the sub-agent start and stop, which we saw in our previous demo, and then tool use, compaction, all things like that. And then they're all triggered automatically, so you don't even have to think about the workflows that are being supported with hooks. It'll just be wired up and then run for you. So what I want to show in VS Code is that we can observe hooks in so it looks like this is still running, which is great because then we can observe hooks running potentially as part of this. We don't have a great UI for observing hooks in in this chat view, but we can look at the output channel. Show output channels in the command palette. There's a lot of different output channels that we support, which is really nice because it helps debug. But yeah, this one is what I'm looking for, which is the Copilot chat hooks. Where did it go? This one. So let me close this and expand so I can have a look at this output channel. So as we see, all of these hooks are hooked up to like trigger automatically. So we see the input that's going into it is just JSON, and then it completes, and there's an output to let it know if it should continue in the lifecycle process. And then this runs every single time. So this is like the 141st time that the hook ran. And that way you know that your hooks are like hooked up properly. Your hooks are hooked up properly, and that they're actually working as you expect. And hooks are also, you can find them in your GitHub folder. Where's my hook that I have? So the one that I have is basically post tool use, making sure that it's formatting correctly. So it just uses like a formatter to go through and enforce those rules after the agent makes changes, and then we can monitor that in our output channel. So where I want to leave you with today, because I know this was a really big, lots of content that we covered, but I think the best place to start is with our instruction files. So these are always on, the biggest bang for your buck probably to set the guardrails. You can access this via /init, another slash command, which is great. And that's a great place to start. If you haven't already, I would definitely recommend going to the awesome Copilot repo, where you can see a bunch of examples from the community and from our team of what works well. And then kind of add different customizations as you see fit and as they come up. Definitely don't try to tackle them all at once, because it is a lot to cover, but just tackle it piece by piece, and then that way GitHub Copilot is customized for you and you're getting the most out of your agents. Thanks.